If until now we worked on learning different features of TypeScript, it's the moment to put them to practice inside this section and in the next one. In this section we will build a very basic backend with Express. And what can we expect from this section? Well, we will use Express 5 and we will set it up with TypeScript and NodeMon. We will learn about two important features of Express, about routing and middleware. We will implement a basic database solution, an in-memory database, let's say it like this. And in the end of this section we will learn about two important concepts. First of all, we will learn about dynamic data validation with a cool library called Zod. And then we will see a solution for dependency share. We will see this at the end of this section. Well, an important requirement for this section would be for you to have basic HTTP or concepts, like what is an HTTP request, response, what is a header, what is a method. If you have this, if you know these concepts, then you can take this class. And you should also be able to use a REST client like Postman. In this section we will use the REST client for VS Code. Well, why I chose Express as a point for practice for this lecture, for this section? Well, you must understand that even with the newest NPM trends, Express is still the most popular backend framework for JavaScript and TypeScript, and this is the reason I chose it. Also, I have experience with it, and you must also understand that this is not an Express tutorial. So in this section we will practice TypeScript. We won't learn Express on all its great features. We will just have a little practice. Well, and if we are talking about practice, let's see what we will build by the end of this section. So let's switch to the workspace. Well, I'm in the workspace, and this is the finished point of our very basic application. It will be just a very simple backend server with two endpoints, the employee manager system. We can just create and then retrieve employees. A very basic crude application. Well, and these are the files that we will be implementing, and let's see how this system will work. If we just send a request to create a employee, we will put the details of our employee right here, and the system will return back a randomly generated ID of our employee. If we want to retrieve this employee right here, we can pass its ID and we can retrieve its details. If we want, we can see all our employees right here. So basic, just a very simple crude application written with Express. This being said, if you don't like Express, or if you are not into backend development, you might just skip this section. For the moment, let's get to work and put TypeScript to practice. In this lecture, we will set up our Express with TypeScript small project. I've listed the steps inside this text file. Let's get to work. First of all, what we need is to have a node project. So let's do this. I'm currently inside this section 12 folder, so I will init a node project right here with npm init -y. Now we have a package.json file. The next step would be to install Express locally inside our project, and here is an important discussion about the versions of Express. Express is known by being or by claiming to be very stable, so it releases versions not so often. Currently we are at the stable version of 4.17 or 18, I don't remember exactly. But for this course I will be using version 5 because currently they claim, if I will open a GitHub issue about this, they say that in 2023 they will be released Express 5, so maybe by the time you're watching this, Express 5 will be released. But Here they say that many people say that they are using this 5 beta in production also for many months now, and it works just fine. So to keep the course more updated, I will be using Express 5 in this section. You can use also Express 4 if Express 5 is not released yet. For the examples I will be working in this lecture, Express 4 and 5 will behave almost the same. So I will install Express 5 right here. Currently this Express 5 has some vulnerabilities, but they are not so important. For in the future, of course, they will be fixed. Now we need to install TypeScript and what we need for Express nodes. So I will install TypeScript along with TS node and the types for Express and for node. Alright, what else do we need right now? We need a TypeScript configuration file, so I will create it. I will not generate it, I will create it. So I will say here new file, I will call this ts config JSON, and I will configure it manually. I want to have the latest or at least very new options. For example, the target will be ES 2022. I'll also set right here to allow synthetic default imports. We are working with strict. As before, our root directory is src, our out directory is dist. I will use ES module interop, and module resolution will be node 16. Alright, what else do we need? Until now it was easy. Now we have to write a minimal Express app. So let's do this. I will first create a folder structure. So here I will say a new folder src, and inside the src folder I will create a new file. I will call this server.ts, and let's write a minimal Express application right here. First of all, I will make this a class. So here I'll say export class server. First of all, we need to import Express. So here I'll say import first of all from Express, and what we want right here is the Express constructor. So here I will say Express as a constructor, Express, and now I will say right here private app is Express as a constructor right here. And now this application contains all the functionality inside Express. Let's move starting the folder, the server inside a method. So here I will say start server as a method. And right here, first of all, I'll say this application, and first of all, let's serve a get request, and let's say that the path to this request will be hello, just to see that things are working. And then we need to provide a callback function which contains the request and the response usually. So here I'll say request of type, and also let's import first of all the request type right here. So here I'll say request and response from Express. You know, there are lots of built-in types in Node.js, but let's make sure that you use the one from Express. So our request will be of type request, and our response will be of type response. Alright, and now inside the callback, let's just add something to the response. So here I'll say response send, and let's just send a simple hello message like this. The last thing that we need to do is to actually start or listen our server, to make our server listen to requests. I will save the port upstairs. So here I'll say const port is, for example, 3000, and now our server will be listening on port 3000. So here I'll say this app listen on our port, inside our port, and let's add a message that we are listening. So here I'll say console log. Alright, and basically we are done. Now all we need to do is to start this server. So here I will say downstairs new server, start server. Alright, let's now build a script that executes this. So here I will say inside the package.json file a script. Let me call this start, and let's simply execute this with ts node, and this will be src server.ts. Let's see if everything works. I will say here npm run start. Alright, and we are getting the message that listening on port 3000. Now we need a way to make a request to our port 3000. Since we are serving a GET request, we can do this request directly from inside a web browser. But we would use something like, we would also need to make more complicated requests. We can use a REST client. And you can use any REST client application you want. A popular choice would be Postman, but inside this course I will be using an extension, a popular extension from VS Code. If you're not using VS Code, you can use any other program like Postman or Insomnia or any other program that is used to make HTTP requests. For this section I will be using the REST client extension. This is the one. I have it installed. If you don't have it, maybe you can install it or use whatever you like. And in order to make requests with this extension, I will create right here an HTTP file. And here I just configured the URL, and the URL should be HTTP, localhost and the port. And now we are sending a GET request. Let's see if this is working. And we are getting a response. As you can see, we are getting the response. Now, the next important point and the last point inside this lecture would be what happens when I will make a change in my application. And this will happen very often when you are developing your change. Well, if I want to make a change, for example, I'm changing the message right here. If I save this, I want to send a request again, but this won't reflect inside my server. In order for it to reflect, I need to stop the server with Ctrl+C, and I need to start it again. And this can be very annoying. And now if I will see, you will see this change reflected. A cool way to reload your application when something is changed and not always manually stopping and starting it is by using a package, a popular package called nodemon. So I will install this. I will call npm install, and I guess this is the last step inside our steps. Let's see. Yes, we need to configure nodemon. So this will be a development dependency. Careful for typos. Alright, and our nodemon in its latest versions works very nice with TypeScript. We don't have to compile it first. It will directly execute TypeScript if you have tsnode installed. So inside our package.json file, I will add a new script. Let's make some room right here. I will add a new script and I will call this dev. And inside this dev, I will call nodemon and our server.ts. And let's see if this is working. So now I will call npm run dev. And now you will see some logs from nodemon that it will start this TS node. And what happens now? Let's see if our request works. So let's make another request. And as you can see, we are getting this hello. But what happens if I will make a change inside our application? Maybe put some other things right here. I saved this. And as soon as I've saved this, nodemon will reload our application. And now if we will make the same request, the change will be also reflected in the response. So in this lecture, we build a very minimal Express and TypeScript application, and we configured nodemon with it. Let's also continue to write our application, not just some hello world examples, in the next lecture. Let's now talk in this lecture about routing in Express. And why is this a very important point? Well, let's look at our basic application. Currently, our application only serves one route. When we are talking about routes, we are talking about the paths to the real application inside our server. Well, if Express sees this hello path, then it will know how to handle this route. If we just want to serve another route, we can just simply say here copy and paste and add here another route. Not so complicated. But let's now think about a big application and like an employee or like a company application, like a server which handles the company internal business. Well, in this case, the things will be much more complicated. And if we look at an example, let's say that we have multiple routes. We have a route that handles everything related to our employees. You know, we can add employees, we can delete, we can update employees. Maybe inside the route of our employees, we have a new route called salaries. And then again, here we handle salaries or vacations and so on, so on. Then maybe we have another route which handles tasks, and these tasks route has other subtasks and budgets and so on, so on. You know, usually when it comes to complexity, the sky is the limit. And even in this lecture, we will see some optimization. For a simple application, it would seem that this is like overkill, but this will prepare you for the real-world applications regarding Express and TypeScript. And in this lecture, we will see how we can organize our routes. Let's see an example, and we will talk about this employees path. Well, let's first make a folder organization inside our application. Let's say that we want to serve everything related to our employees inside one route inside our server. First of all, we need a folder structure, as I said. Well, let's say that and usually I saw this is a good practice, we put everything related to our API inside an API folder. Well, this API will contain a new folder called employees or EMPL, doesn't really matter, this folder. And inside this EMPL folder, we will have some new files. Let's say that we have a file that will only handle routes. So here I will say employee.route.ts. And this file will contain the routes that are handled by our employees. Maybe inside our application we will have another path, maybe with tasks. So here I'll say tasks. And now we know that everything related to tasks is inside this folder, and everything related to employees is inside this folder. We have a router or a router for employees, and in order to simplify things, Express gives us a router object. So to build a route that only handles employees, I will first import the router from Express. Then I will create this employees router, which is a router called as a function. And then we can serve different requests. For example, I will say right here, employees router get. And now, first of all, we need to pass the path. So the path will be simple. And then we need a handler for this request. Because I'm lazy, I will just copy the other handler right here. Add also the request and the response, and here I will say hello from employees right here. Alright, we are serving now a route from inside our employees router, and now let's just export our employees router. So here I'll say export our employees router as a default. Like this. Now let's import this employees router inside our application. And here I will say this app, I will call the use. And now we will make a path for employees. And now we can simply say here, call our employees router. Right now. And let's see if this is working by this point. Let's make a request now. So let's start our application. Alright, let's make a request. And now we want to make a request to our employees. Yes, we are receiving a response for our employees. This means that our router works just fine. And now it is very easy to create new routes only inside this path to our employees. So now if I will make a new request right here and make this a put, save this. Now if I want to make another request, maybe just make another request right here with a put. You'll see this request also works just fine. Well, there's another important point about handling requests. Usually I saw that another best practice is to put our handlers also inside a different file. So we will have one file for our routes and one file for our handlers. So inside our employee folder right here, I will create yet another new file. And I will call this employee handlers or handler.ts right here. And now let's build some handlers for different requests inside our application. Maybe one request for creating a employee and another request for updating or getting all the employees. And what first we will need? We will need the response, the request, and the next function from Express. This is very important because we will be building some handler functions. So let's first create a function that gets all the employees. Currently, I haven't built anything related to getting all employees, but let's analyze this function. As you can see, I've called it getAll, and it also receives a request, a response, and a next function. Usually this is called a middleware, or a function that comes between the request and the response. And inside this function, we can build our response. Currently, we don't have anything because we didn't configure a database, even a very basic one. We will do this in the following lectures. But let's, for the sake of arguments, let's build something right here. Let's make an object, and let's just say right here, name John, something like this. And now, if we want to send these employees as JSON, we can simply call the JSON function with this object. Very important, if there's an error happening, we will simply forward this error with the next function. Let's see if this is working. So inside our route, let's say that for the simple get right here, we will serve this function. So we won't need this handler, this local handler right here. We will use the one from this employee handlers function. So first of all, let's import it. So here I will say import everything as handlers from right here, our handler. And now we can use these handlers inside this function. So here I will say handlers get all, and we can pass this as a function without parentheses. We don't execute it downstairs right here. We simply pass a reference to this function. The router will execute it. Let me delete this. We don't need this. And let's see if this new way of handling objects work. So let's make a request. And yes, we are receiving a valid response. This means that our router works just fine alongside our handlers. Let's move on into the next lecture and also expand our handlers. Let's continue working on our application, and let's create another handlers for our employees. We will create a handler called getById and also a handler called add, which in theory should return all our employees. Well, but this is a great point for us to talk about how types work with Express. Because currently we don't have any types or limited information about what kind of objects are inside our requests and or inside our responses. Well, in this lecture we will see how we can combine custom types with Express. First of all, let's create a new handler called getById, and let's say that we want to get the ID from inside our request. Well, how we can make sure that we have an ID inside this request? Well, by using generics. And the cool thing about Express is that with TypeScript we can have multiple generics or powerful generics that somehow give the shape of our requests and our responses. For example, let's say that we want for sure to have an ID inside our request. Well, here we can say that we have an object, a request that receives an object which contains an ID of type string. Well, now let's get this ID from inside our request. So here I'll say const ID is our request. Then we call the params, and now if we configure this ID right here, then we will have right here an ID of type string. And now simply say, let's just say right here, John, we won't make any query with ID, and let's just add this ID right here to see that we are successfully passing the information from our request to our response. Well, how we can do this? Let's create another route. So inside our routes, let's create another route, another getter, and inside our new get we will say that we want an ID. And now inside the handlers we won't say get all but get by ID. Let's save everything and let's see if things are working. So let's start our server. Well, it started, and let's make the request, and let's make a request for our employees, and let's just pass right here a simple random ID. Let's see if this is working. And as you can see, if we are looking at the response, you will see that we are successfully passing this ID from inside our request to our response. Of course, we won't do this. We just want to make sure that we are getting the information from our request and we can do something with it. Well, we will see what we can do with this information in the following lectures. Now let's try to model the way our objects will look inside our application. For this, I will create a new file inside our folder structure. Let me save everything and clean things up. I will create a new file and I will call this employee.model.ts. And this employee model will only contain information about our employees or the objects that this part of our API will handle. Well, I have completed these types for our employee, and this is the way our objects will look inside our application. An employee which has an ID, a name, an employed at field which is a date, a position which can be either manager, HR or engineer, and a salary. Well, how we can take this model, these types right here, and put them inside our requests? Well, again with generics. So let's open our handlers right here and let's add these types inside our responses. For example, this getAll function will sure return an array of employees. Again, how we can make sure that we are returning an array of employees? Again with generics. And if we want to make sure that we are returning an array of employees, here I will say that I will add an generic with an employee of type employee array. And as you can see, as soon as I'm doing this, I will get a compilation error because it will tell us that our current response is not an employee array. I will just make an empty array for the moment. Okay, I will explicitly make this a type, otherwise TypeScript won't be happy. And again, our getById function will for sure return a response of type employee. So this will be of type employee, or it will be undefined if no employees are found, like this. And now again, we have an error right here. Let's just say right here that all our employees are undefined, like this. Maybe const response, like this and like this. We will handle this in the next lecture when we will implement our database. And in the last part of this lecture, let's think about how the last point of our application will look like, this add endpoint. And this add point should receive a object of type employee and should return back the ID. Remember, usually this is the way we are building things. We are receiving an object, we are adding it to the database, and the database or the application handling the database will return us back the ID of the newly created object. So this add endpoint right here should also return back the ID of our newly created endpoint. So this will say that returns something with an ID, something like this, ID, and this is of type string. Let's in this lecture only configure the types for this response, not write the actual implementation, because also configuring this will be not easy task. So let me just copy and paste one handler right here and call this add employee. And remember, we want to return back something with an ID, so I'll just create a type locally right here, I will call this object with ID, and this is simply an object which has an ID field of type string. And now our request called add employee receives a request which receives first of all an empty object, then it receives an object with ID and also receives an employee, and as a response it responds with an object with ID right here. Currently we are having an error right here. Let me just delete this right now. And now if we want to send back a response, of course we will need to send back a response which contains an ID field, ID of type maybe 1, 2, 3, something like this for the moment. And let's write the implementation inside the next lecture. We will see how we can create a simple database and also we will test it. In this lecture, we will build our own database. And why I chose to do this? Well, of course, nobody builds his own database. And of course, people use popular databases like MySQL, like PostgreSQL. For Express, it's very powerful. It's very popular to use it alongside MongoDB. But I took the opportunity for this lecture to practice our TypeScript skills by writing a custom database, and then if you want you might use or you might adapt the code to any database you like. Well, because this is more simple, we won't spend the time to configure and install a different database. This is a topic for a different course entirely. Well, let's start building, and for this lecture I will complete the code and then explain it. There's no point in watching me type all that code. Well, but how will be the structure? Inside the source folder I will create a new folder and I will call this data, and inside this data let's call our database AwesomeDB because it will be an awesome database. This is our database. Let me write it and I will pause the video, I'll write it, and then we will analyze the code. Well, this is our database. I still have a dependency which I need to solve, this generate random ID. Let me first explain the logic right here. Well, this database will hold elements that have an ID. This is the main point of all the elements inside this database. And the actual database will simply be an array. And as you can see here, we are using generics because we want to make sure that all the elements inside this database will be elements which have an ID. Well, and then we can have different options that are usually popular inside databases. For example, insert. Here we are taking an argument of type t, we are generating an ID for it, and then we are pushing it to our arguments, to our array. In the end, we are returning the generated ID. Well, then we have this getBy function, which will receive a type or a key of our ID right here, the value, and then it will return back a promise of our element or undefined in case the ID is not found. And I've made all these methods right here asynchronous, even if they shouldn't be asynchronous because operations with arrays in JavaScript are not asynchronous, but I made it like this. I've made them like this to simulate better the way a real database will behave. This is just, these are simple array methods inside JavaScript. They are not complicated. They do exactly what their description does. For example, we have find all by, and this is like a basic query. We want to say that we want to find all elements which have a color of type blue, and this will call the filter method on arrays. Well, we also have a method for update, for deleting, and for getting all elements. We won't be using all the functions inside this database inside this part of this course, but we will use this get all elements, the create, and the get by in this course. I still need to implement this generate random ID. In the previous sections of this course I was using this UUID library, but for the moment I will just create a simple file that uses the crypto module. So here I will say id generator.ts, and this is our random generate random ID function with the random bytes from crypto, and everything should be alright by now if I don't have any typos. Alright, we have our ID generator and our database. Well, if we have our database, we could use it directly inside our handler. Right here, create a new instance of our database, our AwesomeDB right here. But I would assume, or I would think that this would be too direct way for a handler function to directly access a database. Again, a complication or a super optimization or an unneeded optimization for a simple application, but usually when your application will grow, you will be happy that you have a different step between your handlers and your databases. And again, usually these classes are called accessors or data access, or any way or any name you want to choose for a file that accesses the database. I usually call them data access. So here inside our employees folder, I will create a new file and I will call it employee data access.ts and make this a class. Again, I've paused the video and brought down the code. There's no point in watching me type all this code. You have it available as a resource. And what we need right here is to add our employees, to get the employees by ID, and to get all employees. Remember, these are our endpoints. And now if we have this data access, we can use this data access in case we have another database implementation, then it would be very easy to change it. But now if we have everything in place, let's see if everything works or if everything explodes and crashes. Well, for this, let's move on into the handler. And for example, we have this get all function right here. We need now to call our employee data access. So here, let's create a new instance of our data access. So here I'll say const data access is new employee data access. Right here, this will also create an instance of our database. And all we need to do right here is to get all the employees from the data access. So here I'll say data access get all employees right here. What's the problem? Yes, forgot the await. Always forgetting the await. Alright, the same get by ID. We have the implementation inside the data access. So here we have the ID at the get by ID. I'll say right here const employee is our data access get employee by ID, and here we are passing our ID, and this employee can be either await. This employee can be either undefined or employee. Well, if we have this employee, here I will say if we have this employee, if our employee exists, then here we'll say res JSON employee, and also we should specify that the status is okay. So status is 200 if everything is alright. Alright, if we don't have an employee, I will say right here else. So if our employee is not found, here I will say res.status 404, and 404 stands for not found. And for this we can send a response message, and here we can say, here we have a typing error because currently we are returning inside our functions both employees and both string. So our response can be either both employee or string. I have a typing error right here because we are either returning an employee or we are returning a string message with our error message right here. This was also implemented, and the last point is this add employee. So here I need first the ID. So here I'll say const ID is our data access, await our data access, add employee, and we can get our employee from our request. So here I'll say request, and if we look at our request body, you will see that this is of type employee right here. If I will look at the ID, you will see that this is of type string, and if we want to add this employee, this only accesses arguments of type employee, and currently our request body is employee because we specified this right here. Now we can simply return the ID. So I will say here employee ID to don't have any problems. Okay, let's save everything and see if everything works. All right, our server is working or not. Let's start the server and let's make some requests. First of all, let's make a request for our employees. Currently, there's nothing returned, but let's make a request for creating an employee. And the requests for creating an employee are post. Let's see if we added this post to our route. Yes, I haven't added this post to the route. Well, a little mess right here, but let's do it. So let's add a new entry right here with the post, and again by all the paths, and our handler will be add employee right here. Save everything. And now if we are making a post / employees and we are specifying that our content type is application JSON, let's see if our employee is worked. All right, what's the problem? I guess there's something with JSON. Yes, we need to specify that our employee's router uses JSON. So here I will say employee router use JSON from Express as a function. And this way Express will understand that it should parse our responses or our request bodies as JSON. Let's try this request one more time. And yes, now our ID is created, our employee is created, and we are returning back an ID. Let's make multiple requests. And now if we want to get all the employees, let's see. We are receiving a response with all our employees. That's great. Let's see if get by one works. All right, I will get these employees with this ID. And yes, I'm receiving also this employee. This means that our application works just fine. You see at this point that we have no validation at all inside our implementation. We can add anything right here, and this is not a good thing. Let's talk about validation and about middleware, more talks about middlewares inside the next lectures. As we developed our application until now, you might have observed a problem, or at least a big problem with it, and that is that we can pass anything inside our create employees right here. When we are making a post request, inside the body of our request, we can add anything. We can add anything as a position, and the server won't complain because we are not doing something called a validation. Well, how we can do this? We can do it with a validator middleware function. A simple function that will also have access to the request, to the response, and we will put this function between the router path and the handler. You know, this is the real way in which we can use middlewares. Well, for this, let's create a new file, a validator file, and we will do this in two ways. In this lecture, we will do it the hard way, manually, and we will write a validator manually against our employee type. And then in the next lecture, we will write it with an external library, a cool library called Zod. Let's write manually our validator, and you will see why Zod is so popular. Well, I will create a new file and I will call this validator. And of course, because this contains a lot of code, I will paste it and explain it. Well, this is our validator, and as you can see, it is quite complex. Let's see what is happening inside this class. I called it validate as employee, and since this is a middleware, it receives the request, the response, and the next function. This is optional, but we will use it inside this implementation. And what we want to do is to make sure that inside the body of this request, we are defining a valid employee. And when we are looking at this type employee right here, what exactly do we really need when we are receiving one for our database? We should say that our employee should have a name, should have a position, and should have a salary. The ID is generated by the database, by the server, and also the employed add field is also generated automatically by our application. So in our case, we want to make sure that what we receive inside our request has a name, a position, and a salary. And the position should be manager, HR, and engineer. Let's see how we can do this manually. So where it's right here, this is our function. And I haven't added any types right here because currently our request body should be any or undefined, and we should just iterate through it and make sure that it contains the right fields. Well, first of all, I'm making different checks. If our request has a name, if it doesn't have a name with an exclamation mark right here, so this is negation, we will throw a field error. And the only reason I've created this field error right here, this simple class field error, which simply extends the error, is for us to set the right status code. So in order, if we are having an error, which is an instance of field error, we will update the status of our response to 400. This means bad request. Maybe 422 is a popular option, but I usually, when there's a bad request, I leave it 400 because this is like debatable. I usually leave it 400 or 404 when this is not found. But currently, this status message should indicate there's something wrong with our request. And what can be wrong? Well, it can be wrong that it doesn't have a name, that it doesn't have a salary, and also that it doesn't have a valid position. And as you can see, there's a lot of code and complicated code right here. This is one problem. The second problem is that this code is not fully connected to the employee as a type. So if something changes right here, if we are adding a new position that is a valid position, then we would always have to remember that we should add that position to our validator, you know. So we should always remember to change it also if our type changes, you know, something really complicated. In the end, we are getting the body right here, and in order to make sure that we are not adding anything else, like for example this other stuff, we are getting only what is concerning for us, the name, the position, and the salary from the request body. Let's see if this validator works. And also, when you are writing a middleware, don't forget to always call the next function. Otherwise, your request will just take forever and it won't end. Well, let's see if this validator works. And in order to check it, all we need to do is to put it right here on the post request between the path and the handler. So right here, I will add the function validate as employee, just as a function, simple as that. Save everything, and let's see now how our request will look like. Let's maybe pass some wrong value to our manager. Let's see. And yes, our validator somewhat works because we are now getting 400 bad requests. So our validator works because it tells us invalid position. If I will put a valid position right here, it should work just fine. But as you can see, if we are getting an error with our application, we are seeing this error as an HTML response. And I've seen websites which just show like this. They show the error message as a response in the client. I think this is very unprofessional. We should see this error inside the console. I guess we also see it inside the console. Yes, but we shouldn't see it as a response inside our request. Well, there's an easy fix for this, and the answer is yet another middleware. So inside our server, directly at the highest level, or maybe also inside the employee router, right here, we can do it anywhere we like, but I usually like to do it right here inside the express at the highest level. We can overwrite the way we are handling errors. So inside our server, I've wrote right here a simple middleware. This use requires a middleware, again, a function that receives the request, the response, the next function, and in our case also receives an error. And currently what we are doing right here, we are sending back the error, but we are not printing it to the console. Let's see if this is working. We are not printing it as a response. And now if we are making the bad request again, right here, you'll see we are getting the error message that our position is invalid, but we won't get the HTML text with the error trace. In the console, we also get all the information about our error. Well, as you see, this manually written validator is very complicated and hard to maintain. Let's see in the next lecture a more easier way in which we can use types and validation schemas by using the Zod library. In the last lecture, we wrote ourselves this very complicated validator middleware. Let's see if there's an easier way to do this, and we will see in this lecture a much more easier way with a cool TypeScript dedicated library called Zod. And Zod is a library that is a validation library. We define a schema and we compare an object against that schema to make sure that that object has the shape that we want. Well, let's see how we can use this library inside this lecture. It is a very popular library. So first of all, we need to install it. It will be a regular dependency, not a dev dependency. So npm install Zod. Alright, we have Zod installed, and now let's write another validator. And because I'm lazy, I will just copy and paste this validator, rename it, and I will rename this to Zod validator right here, and let me delete everything inside the implementation of this validator. So in this try catch, let me just delete everything, inside the catch delete everything, and delete everything. And now our simple function is just a regular middleware. Let's now use Zod. In order to use Zod, we should first import it. So import, first of all, from Zod, we import Z. And this Z contains everything, or at least almost everything that we need from Zod. And what we first need to do is to define a schema. When I first heard about Zod, and I was thinking, and everybody was saying how cool it is, I was thinking that maybe it will just receive a type from TypeScript and it will be directly able to do a validation against it. Well, that's not possible because types don't exist and at runtime. So in order to actually write a library that uses types as a validation, you should, I guess it should be written in C, or maybe it should be embedded in the compiler. It is much more complicated than I initially thought. Well, but Zod does the next best thing. So we need a schema. So here I'll say const employee schema, and now we can call the Zod object as a function, and in this function we will pass a object which will contain all the fields that we want inside our validation schema. And if you remember, in the last lecture we said that we need a name field, a position field, and a salary field. But we can take things to the next level. Well, I have paused the video and wrote the implementation myself, and as you see, our schema expects an object which it has a name field which is of type string, and you know, with this you can add all kinds of constraints about your fields. For example, at numbers you can specify an interval for your numbers as well as a date, And also as position, you know, you can specify it as an enum, and then Zod will know that it should expect only values from this enum. Well, again, this is a one definition, and if you remember, we have another definition inside our model entry when we are specifying our employee. Well, one way in which we could have only one definition of our type would be by using Zod right here. And here I will say type employee is our Zod object and call the infer. And here we can pass as a generic the type of our employee schema. And if we look now at this employee type, you will see that it will look exactly as we wanted, you know. And this would be one solution to only have one source of truth inside your application. As you can see, now we're having a error because the compiler doesn't know exactly what employee to trust. Maybe I will say here Zod employee. And this is a solution to have only types from one source from your Z implementation. I will not renounce these types that we wrote ourselves, but I showed you that this is possible doing with Zod. Now let's write our real middleware function that will validate our objects. And all we need to do is say const parsed result is our employee schema. And here we call the parse method, and it receives the request body. And if something is wrong with this parsing of our request body, maybe the body doesn't contain what exactly it needs, it will throw a Zod error. So here I will say inside our catch error, if our error, call the instance of Zod error right here, then we will specify the appropriate return status code. So here I'll say response status, and it was 400. Basically, we are done writing our validator using Zod. As you can see, a much more easier and cleaner and rigorous way in which we can write our validators. Let's see if this is working. So inside our route, let's use the validate as employee from our Zod validator. All right, let's see if our server is still working. No, it's not. npm run dev. And now let's make a request. And if you remember, we are doing this manager wrong value for our manager. Let's see. And you will see we are still getting a bad request, and it will tell us all that is wrong with our object that we send. For example, it will tell us that this managers is not a valid value, and it will tell us exactly what is valid. And also it will tell us that this position is wrong. Well, let's save this and let's try to run again. And as you can see, we are getting a entry. If you see at our request, if we look at our request, you can see that we are sending also another field which shouldn't be there. Well, is there a way in which Zod can also raise an error if there's stuff other than this? Yes, there is. So if we go at our validator, at our schema, we should make this strict. And if we make this strict, now if we will make again this request right here, it will tell us that, hey, your object that you send me has also unrecognized key, this other key. Well, this is wrong. Let's delete this, save this, and let's send it now. And finally, our response is, our request is accepted by the server. Well, we saw in this lecture how we can use also Zod as a validation middleware. Let's think at the following way in which we can extend our application. We have almost completed this employees part of our API, but let's say that we need another API something looking like a reports that takes data from all over our system. And let's say that we want an information only about salaries of our employees. Well, how we can implement this? Of course, this will need a new entry right here in the side API, a new router, that's no problem. But what is a problem, we will see how we can solve inside this lecture. It will be the access to the information regarding employees. Because currently, the information regarding the employees is held inside this data access, which initializes our database for employees. Well, how we can have access to this data from another point inside our system? How we can solve this problem? We will see in this lecture with something called dependency injection, and we will build our own container for dependencies. You will see it's not hard at all to do in JavaScript. It's one of the reasons I really like JavaScript. Let's first build a new endpoint for our application. So inside this API folder, I will create a new file, a new folder, call this reports. And inside these reports, let's create a new router file. So here I will say reports route.ts, just like we have for the employees router right here. Let's also build a router for our reports. So we have this router. What else do we need? We need a router right here. Let's call this reports router. And now let's serve a get method. So here I'll say reports router get, and then let's just say that this will be on the path to salaries, and then let's just pass a callback. Well, this is the implementation, the very basic implementation. Now the big question is how we can get access to this data access regarding our employees. Well, let's build our container first, and you will see what I mean by that. Let's build a new helper class or a helper file, not inside the API, but maybe inside another folder. And usually what is shared inside my application, I put in a shared folder right here. And let's make a new file called container.ts. And this file will contain the dependencies that we want to make public throughout our application. Because it is a lot of code, I will complete it and then I will explain it. So this is our container, and this will be our dependencies that will be made public. And as you can see, this is a map, not an array, a map of string and any. This means that we can add anything inside this map with a string key. And when we are adding a new dependency right here, I've called this method register, which receives a key and the actual service or dependency that we want to serve. Right here, this is our dependency that we will want to make public, and then when we want to resolve it, we will resolve it based on its key, just like this. Now let's create a new instance of this container. So here I'll say const container is a new container. And now we have an instance, and as you can see, nothing inside until now is public to the outside world. So everything is public, or everything is private to this file. What will not be private, it will be the two methods that will be used in order to resolve or to register the dependencies. And this will be the two methods. One is called resolve injected, and this will be used in order to retrieve a dependency that we want. And as you can see, this is a generic function because it receives a type and it sends back the same type. This will be very useful when we will want to have types for our dependencies. And with the inject dependency, we will just add these dependencies to our container using its key. Let's see if this implementation works. So, as I said, we need an access to this data access object. So here we can just simply register it inside the container. So here I will say how it's the method called, inject dependencies. These are such big words, you know, and this data access. All right. And yes, we need to pass a key, and usually with this kind of approach the key is actually the class type name. This is the one. Let's save this. And now when we want this inside these reports, I'm not making a new file for the handlers. Maybe you can do it afterwards. Here we need a reference to our employee access. So here I will say const employee data access. This is the one, is resolve dependency, or how it's called, resolve injected. Resolve injected, and here we are passing the key from our employee data access. Import this. Alright, and now as you can see, if we look at the type of this employee data access is unknown. But if we will add this annotation inside this function, like this, and import this type, now we will see that we have the right type for our employee data access. And now that we have the data access, we can say that const all employees is await our employee data access, get all employees, and we have all our employees. This should be an array of employees. Yes, and now we can simply map over this array a basic JavaScript function for arrays in which we will send back the names and the salaries of our employees. Something like this. We have all the salaries, and then we return this as a JSON. If we use JSON right here, we should not forget to use this JSON from Express. Alright, we are using this one, and basically we are done. All we need to do now is to, of course, use this router inside our main application. So here I'll say export default our reports router. Let's see if everything works or not. So inside our server, let's now use another router. So here I will say this app use, and this, let's say it's reports, and here we should use report router. Is this the right one? No. Reports router from our router. Alright, let's start the application and see if everything works. Or maybe right here. Yes, we are alright. Starting our server. The server started. Let's quickly create some employees. Let's make this a manager. Then let's just say here Mary, it's a HR. Alright. And let's see if this other request now works. Remember, now our applications, our different parts of our application should communicate with one another. And as you can see, we are receiving the request with our salaries and our names, and everything behaves as it should. As a last note, we could do this container logic. We could do it also with decorators. We can write decorators functions to use the same thing. Maybe I will even write a decorator function and you will see it inside the resources of this lecture. Of course, there are dependencies, much better or much popular and much more powerful libraries which do this kind of stuff, but you know now what's under the hood for them.